Okay, so section 10.3 is what you're working on. And I looked over the videos, and I'll kind of explain a little bit more of what they were talking about in that multimedia library where those videos were. One of the examples that they had in there was when you're going to multiply something like this. And the problem becomes that this is a square root, so you could say it has an index of 2. They just don't write it, but that's supposed to be understood if it's blank. So what we want to do is multiply things that have the same indexes, or indices is what they would say. So in order to do that, you actually have to take it out of the radical form and instead put in rational form. Whenever you hear the word radical, you should think of this funky division symbol with a hook. And whenever you hear rational, you should think of fractions. And that's the difference between rational and radical. But anyway, so we're going to turn this into rational form. And so when you do that, you take the number that's inside the radical, and then you give it an exponent. And the exponent will be in a fraction form. The top number is whatever exponent was on the number inside the radical. So this is just a single 5 sitting here. It has an invisible exponent of 1. So that's what's going to be on top of this fraction. And then since we have this indice or index of 2, that goes on the bottom, like that. So if we do that again over here, we have the 4 inside the radical. And then the exponent on the 4 is that invisible 1 that we assume is on all numbers. We have 1 4 sitting there, so that's why there's an exponent of 1. And so we'll put that on the top. And then on the bottom we have the index of 3. Now the reason that we change it over to this is because now, similarly to what you've done previously, think about your multiplication if you had x to the 4th times x to the 3rd. You learned in previous sections that when you have the same base, for multiplication you just add their exponents. So this would be x to the 7th. So that's the idea that they're doing here. They're saying, look, you know what? We want to change these so that they have the same exponent, and so that we can put them inside of the radical. And so, or I shouldn't say that have them say exponent, but have the same denominator on their exponent. So like 2 and 3 need a denominator of 6, and because 2 times 3 is 6. So if I change this one to have a denominator of 6, it was times 3. So the top has to be times 3 also. So now I have 5 with 3 over 6. And I have, if I do the same thing here, it's times 2 on the top and bottom. So we get 2 over 6. So now what I have is 4 to 6, 2 over 6. Now, what happens now, remember up here, when we changed this into fraction form, the index out here was whatever the denominator is. So if this is our denominator here, we can turn it back into the radical. And that means we have to have a 6 out here, because that's what they have in common now. And now we can put the remaining stuff inside the radical. So it would be 5 to the 3rd power times 4 to the 2nd power. And they're all inside with that 6 on the outside. And then we could clean this up. 5 to the 3rd power is 125. And 4 to the 2nd power is 16. And so then we would have the 6th root of 125 times 16, and I don't have a clue what that is off the top of my head. So let me grab my calculator, and oops, sorry, I know I'm not great on this camera thing. So we have 25 times 16, which I should have known that because 16 quarters make 400. Okay. So we have the 6th root of 400. Now, one of the things that I recommend, actually I was going to say that at the beginning of this video, is that you just make a little list somewhere else on another piece of paper that you can kind of follow and have on hand, so you can identify some of the common roots. Like here I said, well, I know the numbers that are squared. I made a list of them. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. This squared list can be pretty long because those are the real common ones. I went up to 15, I believe, on this one. But the other ones, we don't tend to use them when they're very big because they're just huge numbers. So like 1 to the 3rd power is 1, 2 to the 3rd power is 8, 3 to the 3rd power is 27, and so forth. So I went 1, 2, 3, 4, 5, 6. I only went up to 8 on this one. And this one I only went up to 5. And this one I only went up to 4. We just don't use these very often. Up here above the 3, actually, you will have some, and like this one that we're working on 6. So I would say 1 to the 6th power is 1, and then 2 to the 6th power, just a second and I'll tell you what it is 64. And 3 to the 6th power, 243, is 729. We just rarely get any bigger than that. Okay, so when you look on these lists, well, even here, I don't see a 6 through to 400, but there are some things that I can look at. I can break 400 down. And I'm kind of wondering if some of these numbers, like if 64, I don't know, 64 doesn't fit in there evenly. You know what? I don't think we can break it down. I think we're just stuck with the sixth root of 400, and I'm losing my paper here. Okay, stop